Okay, part 2 of the video. They're gonna get a little bit harder. Let's do number 3 first. So we're given cosecant and cotangent. We need to find secant. So if we start with cotangent, that's gonna be cotangent beta is cosine beta over sine beta. Okay, so let's rewrite that as cosine beta times 1 over sine beta. Just splitting that fraction up. So that would give me cosine beta times cosecant beta. Okay, so we're left with cotangent beta equals cosine beta cosecant beta. And that's helpful because we're given cosecant beta, so we can plug that in. And then we're given cotangent beta. Okay, and we want secant, so we'll just do 1 over the answer we get for cosine theta, or cosine beta. So we'll solve for cosine and then do 1 over the answer to get secant. Okay, so let's plug in cotangent beta is -2 root 10 all over 3. And cosecant beta is 7 over 3. Okay. Oh, sorry. I forgot the cosine beta. So 7 over 3 times cosine beta. There we go. Okay, so we'll solve for cosine beta, and then we will do 1 over that answer. So I'm going to divide both sides by 7/3. And I'll rewrite that. So that's the same thing as having -2 root 10 over 3 times 3/7. And that'll equal cosine beta. Okay, so if you do those out, the 3's will cancel. And I'll get -2 root 10 over 7 equals cosine beta. However, we want cosecant. So we'll have to do 1 over cosine beta is secant beta. Sorry, we want secant, not cosecant. So we'll do 1 over -2 root 10 over 7. So then the 7 will come up, and I'll have -7 over 2 root 10 is secant beta. Then rationalize there, and we'll get -7 root 10 over 20 is secant beta. Okay? Okay, so let's go to the back. Pythagorean identities. So our directions here are to use these identities up top to find each function value. So instead of using 2 separate ones, we'll just use 1 identity and then we'll go from there and see what happens. Okay, so find cosine theta and tan theta of sine theta is -1/3 and cotangent theta is less than 0. So that means cotangent is negative. Okay, so first of all, these all have squares. So when we solve something, we're gonna have to take the square root of both sides. And when that happens, you add a plus minus. So we could have the positive answer or the negative answer. So because of that, we need to figure out what quadrant this will lie in, okay? So let's start with our sine. Our sine is -1/3. So that's negative. But our cotangent / tangent, that's also negative. So what quadrant are we in if they're both negative? That would be quadrant 4, which makes our cosine positive. So when we take the square root, we'll choose the positive answer. If that's a little confusing to you, watch what happens and I'll show you why we take the positive. Okay, so if sine theta is -1/3, let's use this identity here, that cosine squared theta plus sine squared theta is 1. All right, so let's start with that. Cosine squared theta plus sine squared theta equals 1. Okay, and what this really means is cosine theta squared plus the value of sine theta squared equals 1. Okay, and if I know that sine is -1/3 sine theta, I'm going to plug that in here. So I'm at cosine theta squared plus -1/3 squared equals 1. -1/3 squared is 1/9. Okay. So I'm going to subtract 1/9 from both sides. And you want to leave this, keep it a fraction, okay? So 1 is really 9/9. I'm subtracting 1/9. So now I'm at cosine theta squared is 8/9. Okay, so I'm trying to find cosine theta. So when I square root both sides, my answer is really plus minus whatever the square root of 8/9 is, because that's a property of square rooting. Okay, however, we said right here the cosine is positive, so we're going to take the positive value of that, okay? If the cosine was negative, we'd just put negative in front of whatever we found. So cosine theta will be, if I simplify this, the square root of 8 is 2 square roots of 2, and the square root of 9 is 3. Okay, so that's my cosine theta. 2√2/3. Now, let's just use the fact, even though it says to use a Pythagorean identity, let's just use the fact that tan theta is sine over cosine to find the tangent, because it wants the cosine and the tangent. All right, so let's do this. Tan theta will be what they gave us, -1/3. Hold on, let me rewrite this. So this will be -1/3 times 1/2√2/3. So tan theta really equals -1/3 times 3/2√2. If I bring the 3 up here, the 3's will cancel. And then we got to rationalize. So it'll be -√2/4. That's your tan theta. Okay, so we used an identity to find cosine, then we did sine over cosine, simplified, rationalized to get tan. Okay, so let's do that again here with, we have tan, sine, secant. Okay, so secant theta and tan theta have a relationship. It's that tan squared theta plus 1 is secant squared theta. Okay, which really means tan theta, the value of that squared, plus 1 is secant theta, the value of that squared. Okay, and we know secant theta. So I'm going to plug 6/5 in for secant theta squared. And then we're eventually going to have to square root. So let's decide if we're going to use the plus minus or the minus. Okay, so I have a secant which deals with cosine being positive. So our secant slash cosine are positive. And then this means sine is positive. So what quadrant would cosine and sine be positive? Quadrant 1. And so that makes our tan is still positive. So all of our solutions should be positive. We'll choose the positive value when we square root both sides. Okay, so let's plug in secant squared, 6/5 squared. So I'm at tan theta squared plus 1 is 6/5 squared, which is 36/25. So I'm going to subtract 1, which is really 25/25 to both sides. Okay, so this will give me tan theta squared is 11/25. And when we square root both sides, by the way, you definitely do not make that a decimal. We're dealing with fractions. No, don't make that a decimal. So therefore tan, that's just a comma. Tan theta is square root of 11/5. Okay? Tan theta is square root of 11/5. Now, let's use the quotient that tan theta is sine theta over cosine theta to figure out what it's asking for sine now. But we're given secant, so that'll help us out, which is sine theta times 1/cosine theta, which is sine theta times secant theta. So now I'm at tan theta is sine theta secant theta, and that works because we know secant theta is 6/5, and we know that tan theta, we just found that, is square root of 11/5. Okay, so this is sine theta, and I can just solve for sine theta. So I'm going to multiply both sides by the reciprocal. Okay, and on this left side, the 5's cancel. So square root of 11/6 is sine theta. Okay? And I kept using thetas, even though it said x. Sorry, those should all really be x's, but you get the point. Okay, so let's look at cofunction identities here. And basically what this means is like a shift in your graph. They end up being the same. Like sine's graph was extremely similar to cosine if you just shifted it. Okay, so that's where these identities are coming from. Okay, also are even odd identities. We kind of talked about this a little bit with your unit circle, trying to figure out what ends up being equivalent. So basically sine of negative theta is negative sine theta. Same with tangent, but for cosine and secant, they're actually the same. So if I took the cosine of negative 30, it'd be the same as the cosine of 30, for example, because cosine's actually positive in that quadrant 4. Okay, so we're gonna use those ideas to find these answers. Okay, so let's do, if sine negative theta is negative 0.97, find cosine of pi/2 minus theta. Okay, so let's deal firstly with our even odd identity. So I'm gonna use sine negative theta. That's negative sine theta, and I'm gonna solve it for sine theta. Okay, so this means that negative sine theta is negative 0.97. So if I solve it for just sine theta, it's 0.97. Okay, and what was the whole point of me solving that for sine theta? Because of the next problem. So cosine pi/2 minus theta is equal to, right here, same thing as sine. So we've essentially just found our answer. Okay, so cosine pi over 2 minus theta is sine theta. Those are equivalent. And what was sine theta? 0.97. So that's your answer. Okay, next. Tan negative theta is negative 2.36. So tan negative theta, oh, this is alpha, by the way, not theta, alpha, Greek letters. So this will be negative tan alpha is negative 2.36. Okay, if I divide those out, tan alpha is 2.36. Okay, so I solved that for tangent. And I solved that for tangent basically because it wants cotangent alpha minus pi over 2 for the answer. Okay, and if we look at cotangent, theta, no, tangent theta, sorry. That's cotangent pi over 2 minus theta. Okay. So what happens here is that those don't match up exactly. Those don't match up exactly. All right, so if we're given this, this would equal tan alpha, and we know tan alpha. We need to change cotangent around. Okay, so this is the same thing as cotangent of negative, flip them around, pi over 2 minus alpha. Okay, and cotangent of negative theta is the same as negative cotangent theta. So this is the same as negative cotangent pi over 2 minus alpha. From this identity right here. Okay, so now I actually know what this is because that's tangent. So negative tan alpha, that's what we're equivalent to now, and I know tan alpha is 2.36. So that final answer there is negative 2.36. Okay, last one here. So secant beta minus pi over 2 is negative 3.62. Find cosecant of negative beta. Okay, so these are kind of flipped around from what we've been doing first. So let's try to write secant beta minus pi over 2. Let's try to solve that and then we'll translate to cosecant. Okay. So we know that secant theta, hold on, cosecant theta is secant pi over 2 minus theta. Okay, that was given to us, and we want to get cosecant out. But these are mixed up from our rule. So we're going to have to do the same thing here. Secant, this is equivalent to secant of negative beta minus, oh shoot, I wrote the same thing. Okay, so we're going to change this. This is equivalent to secant of negative pi over 2 minus beta. Okay, because that's what our rule has. It has pi over 2, then the angle, which in this case is beta. Okay, so now we're going to use our secant even on angle here to help us. Secant of negative theta is equivalent to secant of theta. So this is going to actually be the same thing as secant of pi over 2 minus beta. Okay, and that all equals negative 3.62. All right, so we want to find cosecant of negative beta. So let's deal with that now. Cosecant of negative beta comes from here. It's negative cosecant theta. So it's the same thing as negative cosecant C beta. Okay. And so we can now change cosecant beta to secant pi over 2 minus beta because they're equivalent, and that's what we just solved for here. So pi over 2 minus beta is negative 3.62. Okay, so now we're at equals negative secant pi over 2 minus beta, which is negative 3.62, which is 3.62. That's your final answer there.